Hmm. I wonder what could have caused that.
I know. So, you want to know the difference between physical and chemical changes. First, you need to understand what is actually changing. You see, matter is what's changing, and matter can be described as anything that has mass or takes up space. This dog is matter. This dragon is matter. This entire snowy mountain is matter. As you can see, mass is anything and everything. Although, one common concept that is often confused is things such as light, like the rays of light behind me. You see, light is a transfer of energy, and that's not mass. And those two things are different, but that's a whole nother concept. Now, to get the best understanding of what physical and chemical changes are, we first need to look at the definitions of each. A physical change is a change that affects the form of a substance, but not its composition. A chemical change is a change that results in the formation of one or more new substances. Now that we know the definitions of physical and chemical changes, let's look at a few examples of each. Right here you can see a stone stacked up in 3 different forms. As you can see, it has different colors and different shapes, but it's still the same stone. These are physically different. There's a physical change between each of these. Right here, we can see a difference in state between each of these liquids and solids. Right here is water and ice. To change from water to ice requires a physical change because it's still the same compound. The same here. This right here is magma or lava, and that is magma stone. To change between the two just requires a physical change. Now, these are all examples of physical changes, but this isn't all of them. Physical changes are anything that affects the form of a substance or an object, but doesn't change its actual composition. This includes changing the color of a sheep, breaking a block, or even crafting slabs from wooden blocks. Now that we know what a physical change is, it's time we talk about chemical changes. A chemical change is a transformation where one or more substances are transformed into new substances with different properties. This means that the bonds are broken and new ones are formed. Now, in order for a chemical change to occur, a chemical reaction must happen. Any of the following are chemical reactions: combination, decomposition, single replacement, double replacement, and combustion. Now, I won't go into depth about which each of those are and what they all mean, but basically, the chemical formulas or the chemical compound of each substance or object that is being changed has an alteration that changes the formula itself. Now that we know what a chemical change is, let's discuss some common examples of chemical changes in our world today. As you see right here in front of me, I have a furnace, a blast furnace, and a smoker. If I were to open this furnace and place a piece of sand into it, it will undergo a reaction, a chemical reaction called combustion, in which it will become a completely new substance. As it finishes smelting, it becomes glass. The same thing would occur if I were to put this raw iron into this blast furnace, or if I were to put this beef into this smoker. As you can see, all are undergoing chemical reactions and changing to completely new substances. Another common form of chemical change is oxidization. As you can see on the far left, the original copper block is a dark orange color and it's very pure. As it moves further right, it begins to oxidize and have a chemical reaction that causes a chemical change to the copper block itself. Now, although it may look like it just changed color, the difference between the copper block on the far left and the copper block on the far right is the outer brim of rust that is formed. This is because it chemically changed and reacted with the air around it. This is why Lady Liberty is green. She used to be copper orange, like the one on the far left. Our final chemical change example would be brewing potions. Now, brewing potions in Minecraft is quite complicated, so I won't get into that. But as you know, applying heat to two bottles, often one with water and one with another substance, creates a new type of potion. This change happens because heat is added and two substances are combined to form a completely new substance. This is why it's a chemical change, because something completely new is formed in the end. Now that we know what a physical change and a chemical change is, it's time to discuss properties that make them unique from one another. A physical change does not change the composition of an object or a substance, while a chemical change does. Physical changes are usually reversible. That means you can change it back into what it was originally, while chemical changes are not. They also form a new substance, that being chemical changes. A physical change does not form a new substance and remains the same substance before, but just with some alterations. And finally, the energy within a substance or an object changes whenever a chemical change occurs. That often means it's a change in the heat of an object, the light that is produced, or a gas that is produced. But in a physical change, there's no energy change. And although it may happen sometimes, it is not due to the physical change itself. With this information, you now know the difference between physical and chemical changes. I thank you so much for watching this video, and I hope you find all the information useful. If you're seeing this and you're my chemistry teacher, this took way longer than it should have, and I ask you to be graceful. Also, would just like to let you know that Cole did all the behind the work. He made the thumbnail and everything else. Although you may only hear my voice in the video, Cole did do his effort. I swear. Thank you so much for watching, and thank you for a good year in chemistry. Goodbye.